Alrighty, good morning mathematicians. In this video today I'm going to be walking through lesson 3.4 in the unit of filling and wrapping. So we're continuing our discussion of circles. Okay, and we're gonna determine, well, what exactly is the relationship between the area of a circle and its circumference, right? How are these two different measures related to one another? Okay, so the first thing that I need you guys to do is take a look at this circle of pizza, and then it's rearranged into this kind of loosely shaped parallelogram. Okay, so what you guys notice is the same about these two shapes. What are some of the observations you are making? Well, you might notice that in the circle we have 8 slices of pizza, and in the parallelogram we also have 8 slices. So both shapes have 8 slices of pizza. But can we make this observation a little bit more mathematical? If you're thinking about area, right? How do the areas of the circle and parallelogram compare? In other words, they have the same area. Okay, another observation you guys might have made is that the radius of the pizza, right, going from the center to the side of the pizza is the same length as a pizza slice. So couldn't we say that the height of the parallelogram, let me fix this really quick, the height of the parallelogram is the same as the radius? So we'll say the radius is the same as the height of the parallelogram. So these are big observations here. These are pretty important because they're going to help us figure out that relationship between circumference and area of a circle. So if the radius of a circular pizza is 6 inches, what are its circumference and area? So we talked about some formulas. Circumference is equal to either pi times your diameter, or you can use pi times 2 times your radius. You guys might have heard also it rewritten as 2 times pi times r. This is a little bit more standard, whereas this, I always just want to remind you that, you know, your diameter is just 2 times your radius, so that way you don't forget and you don't get confused. Why am I multiplying pi by 2? Just remember that multiplication is commutative. Okay, and then we have our area formula, which is pi times the radius squared. So now all we got to do is just use these two formulas. So the circumference is equal to pi times 2 times your radius, which is 6. So it looks like we're going to have 12 times pi. So if you type that into your calculator, we're going to round to the nearest hundredth here. 12 times pi, yes, use the pi button. And then, so we get approximately 37.699, so I'm just going to round that up to 37.70, and we're in inches, right? So inches squared. Oh, excuse me, inches. This is circumference, not area. Okay, and then for area, pi times 6 squared. So we get 36 times pi, which is approximately 113.097. So I'm going to round that up to 0.10, and now we are in inches squared. And there we go. There's the circumference and the area of a pizza that's radius is 6 inches. Okay. We already talked about question 3.1. Right? Estimate the height and the base of the parallelogram. Well, we've talked about part of it. So we know the radius is equal to the height of the parallelogram. Okay? But now we need to find the base of the parallelogram. So if you notice here that we have 1, 2, 3, 4 pizza slices, right? And 4 pizza slices in the circle is exactly this. So one might even say that these 4 slices is half of the circumference. So the base of the parallelogram is half of the circumference. What is the approximate area of the parallelogram? Well, remember that the area of a parallelogram is just base times height. So we're going to take our base, which is half of 37.70. And remember, this is approximate, you guys. That's why it says approximate the area, because it's not exact. So our base is going to be approximately 18.85. And we're going to multiply that by the height of our parallelogram, which is the same as our radius. And the area of the parallelogram is approximately 113.1. Hey, look at that. The area of the parallelogram and the area of the circle are exactly the same. That's what we're going to write for question 3-3. They are the same. Hopefully your mind is blown. Okay, let's keep going. Question number 4. Sarah thinks the area of the parallelogram is the same as the area of the circle using the following formula. Evan thinks about covering the circle with radius squares and using the formula A equals pi r squared. If the radius is 6 inches, how did the two formulas compare? So all we're going to do is we're going to test both of these formulas. So I'll use Sarah's formula in red. So the area is equal to 1/2 times pi times the diameter. Well, if the radius is 6 inches, that means the diameter is 12. So I'm going to multiply pi times 12. And then I'm going to multiply by the radius again. Okay. And then for Evan's formula, yes, he helped me write this lesson. We're going to do the normal circular area formula, so pi times your radius squared. So we already solved the right side here. This is approximately 113.10 square inches. Okay, so let's evaluate the left side over here. Remember that multiplication is commutative, so you can multiply in whatever order you want, right? Because everything in here is being multiplied. So I think what I'm going to do is I'm going to multiply 1/2 times 12. So half of 12 is 6. So I'm going to rewrite my equation, pi times 6 times 6. In my right side equation, I can rewrite this as pi times 6 times 6. This right here should give it away. These two formulas that these two students came up with are exactly the same, which is actually, let me change that to approximately 113.10. We have units, Mr. RG, square inches. And there you have it. That's lesson 3.4. If you have any questions, please let me know. Otherwise, I will see you in the next video.